Good day, everyone. I'm Yunazal Aswanda, and I am part of Group 7. So before we start, here is our objectives. First is to define what is sequence and give some examples of it. Next is to acknowledge the use of sequence, and then to be able in finding a term given its position. Our title is Understanding Sequence. And then our theme is understanding how the concept of a sequence is utilized in our daily lives.
Hello everyone, I am Princess Beltran, and after my discussion, you will learn to predict what number comes next in a series of numbers. Patterns are all around us. It could be a repeated items, shapes, images, or even numbers. And so, remember this. Number sentence is a list of numbers arranged in a row. And we call each number in a sequence a term, okay? So, what is sequence? Sequence is a group or a series of numbers that follows a certain patterns. It is fun because you have to find clues to complete them. For example, 1, 2, 3, 4. So what comes next? Yes, 5. Because we simply add 1 to the next number. And we used to count it every day. Here's another example. 2, 4, 6, 8. Now observe that numbers in this sequence are increasing by 2. So 2 plus 2 is 4, and 4 plus 2 is 6. 6 plus 2 is 8. So the next number is 10. Let us have some more example. 10, 9, 8, 7. What do you see in this sequence? What do you think its pattern? Yes, it's decreasing. So, when the number is decreasing, we have to subtract. And in our example, we have to subtract 1. So 10 minus 1 is 9, and 9 minus 1 is 8. 8 minus 1 is 7, and 7 minus 1 is 6. And now you have it. You can now determine what numbers comes next in a sequence. So, let us proceed to our next lesson.
Good day everyone. By the way, my name is Eliza Maybibungan, and for today's discussion, I am going to discuss what is arithmetic sequence. An arithmetic sequence is an ordered set of numbers that have a common difference between each consecutive term. For example, in the arithmetic sequence 3, 9, 15, 21, and 27, the common difference is 6. The arithmetic sequence formula is a sub n is equals to a sub 1 plus n minus 1 d, where a sub n is the nth term, a sub 1 is the first term, n is the term position, and d is the common difference.
Another example of arithmetic sequence. So the example that I'm going to show is consider the arithmetic sequence of 5, 11, 17, 23, 29, and so forth. So what is the value of the 12th term of this sequence? In these examples, we were gonna find the value of 12th term of an arithmetic sequence using the formula of an equals to a sub 1 plus
As we learn about sequence, we will come to tackle this particular sequence, which is the geometric sequence. So let us begin by giving the definition of it. What is geometric sequence? Geometric sequence is a sequence of numbers in which the ratio between consecutive terms is constant. The best way to understand it is by giving example. 2, 4, 8, 16. So how it became 4? By multiplying it into 2. 2 times 2 is 4, and 4 times 2 is 8, and 8 times 2 is 16. So to have the next term, we need to multiply it with its constant number. So our common ratio here is 2. So the formula that we will use is a sub n is equal to a sub 1 multiplied by r raised to n minus 1. A sub n is the nth term, while a sub 1 is the first term. Then r is our common ratio, while n is our term position. Now we are down to our last topic, which is the Fibonacci sequence. Have you ever counted the petals of a flower or seen the leaves of the cacti and seeds of a sunflower arranged in both left and right-handed spirals? Do you know that those stuff are part of the Fibonacci sequence? But first, what is the Fibonacci sequence? Fibonacci sequence is a series of numbers in which each number is the sum of two that precede it. Starting at 0 and 1, the sequence will look like this. 0 followed by 1, then followed by 1, then 2, then 3, and then 5, and so on. Because 0 plus 1 is 1, and 1 plus 1 is 2, 1 plus 2 is 3, and then 2 plus 3 is 5. So basically, if you're going to observe carefully, every number in the series is the result of by adding the numbers before it. So the individual numbers is referred to as the Fibonacci sequence.
Another example is an egg. As I was cooking my breakfast this morning, I noticed that eggs also follow the pattern. The proportion of the egg shape are closely associated with the golden ratio. After shooting an egg photo, I superimposed a couple Fibonacci spiral onto it. I was pleasantly surprised at how well they lined up. See this picture to understand the association of the egg and the golden ratio. Next example is our hands. We have two hands, right? Both of which have 5 fingers. And as you can see, each fingers is divided into 3 parts. 1, 2, and 3. All of these numbers are Fibonacci numbers. And as we clench our fist, Fibonacci sequence will be applied because our hands allows itself to form a perfect curl when we clench our fist. And it shows the Fibonacci spiral.